Hello, welcome back to another video. Pew, 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 pew. I don't know why I did that. Um, so I've got a joke. Man, one day I'm gonna run out. What happened when the limbo champ walked into a bar? He lost. Oh yeah, jokes. Okay. Okay, so we talked about vectors and their notation and kind of like a little bit of an intro with vector addition and subtraction last time. Today, we're going to look at components and column vectors. This is, I guess, how it's like the mechanics of it. So it's how it actually moves. It's how you actually calculate things. It's how you actually get questions. Okay, so this is probably the more fundamental part of vectors. So let's take a look. There's two different ways to, I guess, express vectors. It's either component form or column form. And the most important thing is, again, we're talking about a two-dimensional space. Okay, so again, for extension one, we're talking about a two-dimensional space. For extension two, you talk about a three-dimensional space. So we talk about I and J in extension one. So I being the horizontal movement, so it's kind of like the new x-axis. And then we talk about J as the vertical movement, so it's kind of like the y-axis. And then if you're in extension two, it's like the depth. So there's kind of like I, J, and K. So it's like the z-axis. All right, but again, we're only talking about a two-dimensional space for extension one. So we're going to leave that for another video. Maybe if I get enough likes and subscribers, I will make a extension 2 channel. Maybe. We'll see with my current 56 subscribers. Woo. Okay. Component form and column vector form. So the way that component form looks like is you break it into your components. Makes sense. So you have your horizontal component, and then you have your vertical component, right? So xi plus yj. So how that kind of looks is realistically, it'll be something like 2i plus 3j, something like that. Okay, again, we kind of give the squiggly lines under our i's and our j's, showing that we are indeed talking about a vector. Okay, now that is component form. We break it into, there's a horizontal component, there's a vertical component. That's what it is. Now, if we talk about column vector form, it means that we write it in a column. So let's say, for example, it'll generally be like this. So I is at the top, J is at the bottom, and we kind of put like a bracket around it. And that's it. That is honestly it. So a numbered example, if I use the same, oh, okay. Oh, okay. That 20 minutes and 7 seconds, really specific. If we use the same 2i and 3j, it'll look like this. So just 2 at the top, 3 at the bottom. It looks very similar to combinations, but just be aware it's this little squiggly line out the front that gives it away that we're not talking about combinations, we're actually talking about vectors. Okay, so these two are kind of how we rewrite each different one. And so maybe to be more specific, I should have written these as x and y. Okay, so it's kind of like it's an x, lots of I, or a xi plus yj, like that's how it's written. So in the same way that 2, 3 would be 2i plus 3j. Okay, hopefully that's making a bit of sense. Now, there's a couple things about this. So if I'm talking about a unit vector, it just means it's a vector of length 1. Okay, it's a vector, but 1 unit of it. So the notation, if A is a unit vector, is it just kind of looks like a vector, but it's kind of got a little hat. And again, I'm not very good at these little squiggles, but that'll do. So if you've got, let's say if A is your vector, to make it a unit vector, we put the little hat on top. And the way that we would calculate it is it's just going to be the vector, but we're going to divide it by the length of itself, which is kind of makes sense. So if I was to write the whole thing out, it's unit vector, which is denoted with that little hat. is given by the normal vector divided by the length of itself. Okay, kind of makes sense. Now, let's smash out a couple of these ones here. This is just to show you how all these kind of work. So A is going to be 3i minus 4j. So to find the length of it, think of it as it's kind of like, it's kind of like Pythagoras, right? And so I've got 3 in the horizontal direction, 4 in the negative direction. So what is it? Vertical. So this is 3i, this is minus 4j. And so I'm talking about that direction in space, okay, from here to here. Now, how do I find the length? I'm going to use Pythagoras. All right, so in other words, it's going to be the square root of 3 squared plus negative 4 squared. And that just gives us 5, okay? If you calculate that, it's just your Pythagorean triad. Now, if I have 2, that's, again, that line. Oh boy, did I talk about it today? You haven't talked about it last time. I probably missed it. Okay, I did miss it. Sorry from the previous video, but the length is denoted by absolute values. Okay. So that's what it is. And normally when we talk about length in vectors, we call it a magnitude. Okay. So that's what it is. Sorry, last video. Okay, so now if I've got that there, we found the length of A, that's fine. Let's move on. If I've got 2 lots of A, take away B, it's just going to be, and I'm going to write it in its column form because it just tends to be easier to do the math with. It's going to be 1 on 2. The reason being is because it's 1 lot of I, 2 lots of J, so 1 at the top, 2 at the bottom. And then same thing with the 3 on top, negative 4 on the bottom for A. And so here we just kind of treat it as if it was kind of normal math. So 2 times 3 is 6. And then I've got take away 1 still. And then I've got 2 times the negative 4 means I've got negative 8 minus 2. And then honestly, that's about it really. 6 minus 1 is 5. And then I've got minus 8 minus 2, which is minus 10. And that'll do it. If you really want, you can simplify it a bit more, but I would leave it as that. If you want, you could take the 5 out the front, but I would leave it there. Let's find the unit vector of C. So again, C is negative 3i plus 4j. So in other words, it's going to be negative 3i plus 4j. And I'm going to divide it by its length. So it's going to be the length of negative 3i plus 4j. And so here I know that's just going to be minus 3i plus 4j over 5, because I know that the length of that is going to be minus 3, and I'll write the whole thing out so you can see. It's going to be minus 3 squared plus 4 squared. So I know it's just going to be 1 on 5 times negative 3i plus 4j. And that there would be your unit vector. So it's just a vector, but it's got a length of 1. Again, I think with D, I might let you have a go at this one here. It's just going to be calculate the insides first. So what is C take away 2B? Let's do it together. C is negative 3, 4. Take away 2B, and B is 1 on 2. So in other words, it's going to be minus 3, 4, take away 2, negative 4. Hold on, just 2, 4, sorry. And then if I minus these together, minus 3 minus 2 becomes minus 5. And then 4 take away 4 is just going to be 0. So in other words, this is just going to be minus 5i, right, plus 0j. So not really needed to write there. And so the distance of this one's actually quite easy. this one means that the distance of negative 5i just becomes 5. And the last one, if I want the vector a, b, so all of these are, I guess, different vectors. If I want to find the vector a, b, the easiest way to do this would be, it's just going to be b minus a. Okay. Because the idea of this is a would be somewhere here, kind of a, b would be somewhere there, going to be b. So if I'm going from a to b, again, using vector, for this one would be vector subtraction. It would just be b minus a or a minus b, whichever direction you've got. For this particular case here, it's just going to be b minus a. So b is, man, if you're watching my video, kudos to you, because this is a mess right now. Okay, b minus a, and b was 1, 2. And again, I just like using column form because it makes my math easier. But if you prefer the i's and j's, maybe I'll do that for this example here. So it will be, b is I plus 2j. Right, and then I'm going to take away a, which is going to be 3i minus 4j. 3i minus 4j, and bracket everything so you kind of remember what is minus with what. And at this point, we just collect like terms. So it's going to be 1 take away 3, which is minus 2 lots of I. And I've got 2 lots of j, take away 4 lots of j. It's going to be plus 2 lots of j minus 4 lots of j. So that's going to be plus 6j total. And that's it. There's your vector. If you really want, you can write it as this. But yeah, that's it. Now below, I've left some, I guess, more difficult questions. I'm not going to take the time to spend. I'm not going to take the time to go through them because I feel like this video is already long. And everything is just going to end up being a application of what we've kind of done. Now, again, just plot your points on your Cartesian plane, plot your vectors there, and then everything is stuff that you already know how to do. Find the angle of inclination, testing if points are collinear. I'll leave these here, so if you need to pause it, take a look at the working. Finding scalar values. This is just a fancy way of saying find, solve simultaneously. That's honestly really it. Okay. So look, I might leave that there with you guys. If you do want me to go through them, how about you leave a comment? And if I get enough likes, maybe I'll do it. But for now, I'm not really getting paid to do this, so whatever. I hope you enjoy, and I'll catch you guys later. All right, bye-bye.